Hello, and this is part two of integration practice problems. And these practice problems will require a review of trig identity and u-substitution. Okay, so let's start with one. We have the integration of cosine x times secant x all over cosecant x times it by dx. So what I'm going to do is I'm going to break it down, use my trig identity to simplify. So cosecant x, I can't really do much. It is what it is. But secant x, I can rewrite that as, in terms of cosine, it would be 1 over cosine x, right? So rewrite secant x as 1 over cosine x. And then on the bottom, cosecant x can be written in terms of sine would be 1 over sine x. And then you still have this dx. Okay, so what you would do is kind of multiply. This is your numerator, and this is your denominator. So we have like kind of like a complex fraction. So cosine x cancels. So you're just left with 1 over 1 over sine x. So we definitely have a complex fraction. This is your numerator. This is your denominator. So let's fix it up. So we can rewrite this as 1 divided by 1 over sine x. Cross multiply. So 1 times sine x is sine x. 1 times 1 is 1. Okay, so what is the integration of sine x of dx? That is that's just something you should know. It is the integration of sine x is negative cosine of x plus c. Always don't forget your plus c. Okay. Let's move on to 2. So on number 2, we have the integration of cosine x all over 1 minus cosine square x times dx. So I am definitely going to use one of your Pythagorean identities, and I'm going to use this identity. So somehow I'm going to replace this with something. So I have to somehow make this into this. So maybe if I subtract cosine square x from both sides, you get sin square of x equals 1 minus cosine square of x. Okay, so this would be simplified as, so this top is just cosine x. The bottom 1 minus cosine square x is just sin square of x, because we just simplified it. And then we have a dx. Then what I would do is I would not use any more substitution. I would just kind of like rewrite it. Well, I can rewrite sin square x as sin x times sin x, right? So that's what I'll do. So this one right here, sin square x, could be expressed as sin x times sin x. And then you have a dx. So over here, this sin x does have like an invisible 1. So you have like 2 parts. So how can I rewrite cosine x over sin x? Well, that is also called to saying cosine x over sine x, or x over y, is the same thing as cotan x times, and then how can I rewrite 1 over sine x? That is the same thing as cosecant x dx. Okay, and then this one, this is a known integration, trig integration. The integration of cotan x, cosecant x is just going to be negative cosecant x. And then don't forget the plus c. Okay. Number 3. The integration of sin x plus sin x plus sin x plus sin x times cosine of 2x all over sin of 2x. Okay. What should I do? Well, we're gonna have to know one of your identities. Well, on the numerator, is there anything we can do? Is there anything we could factor? Yes, it looks like they both have a sin x, so I'm going to factor out a sin x. So this would be 1 plus cosine of 2x. And then on the bottom, sin of 2x is I think it's a double angle. So that could be expressed as, yeah, sin of 2x can be expanded as 2 sin x times cosine x. Okay. Now what? Use your double angle. So did you also know that 1 plus cosine 2x it's a double angle, so it can also be expressed as 2 cosine square of x minus 1. So you have to know your double angle formula. So also, wait. Over here, what do you see now that cancels the sin x? So you're left with 1 plus cosine 2x all over this sin x cancels. You're just left with 2 cosine of x. And then we said that this right here is a double angle, and that could be expressed as 2 cosine square x. Sorry, no, cosine 2x can be expressed as 2, it's a double angle right here, not the 1. So cosine 2x, so this one stays the same, and then the cosine 2x can be expressed as 2 cosine square x minus 1. So this cosine of 2x is a double angle, and it can be expressed as 2 cosine square of x minus 1. So that's what I'm going to do. I'm going to replace this with that. And then it's all over 2 cosine x. Okay, clean it up. So on the top, what do you see that cancels the ones? So you're left with 2 cosine square of x all over 2 cosine of x, and then you have a dx. And then what do you see that cancels the 2's? And then this cosine x, this just becomes a 1. So it's basically the integration of cosine x dx. And then that was just sin x. Let's see. So that's the answer 4. Okay, number 4, the integration of e to the negative 2x. So this one you have, I would use u-substitution. There's no other way I can think of. And the u-substitution I'm going to use is negative 2x. So then with u-substitution, you take your du. So what's du is the derivative of negative 2x, which is just negative 2, and then don't forget you have a dx. And the thing is, we don't have a negative 2 inside the problem. We don't have it here, so we have to get rid of this negative 2. So the only way to get rid of it is multiply both sides by each side by negative 1/2, right? So this is going to be negative 1/2 du. And then on the right, negative 2 times negative 1/2, that cancels, so you're just left with dx, which is perfect because we have a 1 and a dx here, so that's perfect. So you can rewrite this as e, and then you're going to replace negative 2x with u. And then you're going to replace 1 and dx with negative 1/2 du. And then since negative 1/2 is a constant, you could just take it out. And then you have e to the u du. And what is the integration of e to the u? It's just e to the u, and then you still have to multiply it by negative 1/2, and then don't forget the c. And then your final answer is negative 1/2 e, and then your u is, what did we say? Our u was negative 2x plus c. So that's your final answer. Okay, next one. We have the integration of secant of 6x plus 4, tan of 6x plus 4. I most likely will use u-substitution, but before I do my u-substitution, can we take out a constant? Yes. This has an invisible 1, and then on the bottom is the 2, so we can factor out a 1/2. So we have secant of 6x plus 4 times tan of 6x plus 4, and then you have a dx. So yes, I'm definitely going to use u-substitution, and my u value will be 6x plus 4. And then my du would be the derivative of 6x is 6, the derivative of 4 is 0, and then don't forget you have a dx. Thing is, I don't see a 6 anywhere here, so I have to get rid of the 6. To do so, I'm going to multiply both sides by the reciprocal of 6, which is 1, 6, 1, 6. This is 1, 6 du. And then on the right, 6 times 1, 6, that's just 1 or dx. You can rewrite this problem as 1/2, and then you have secant, and then just replace this with u times tan of u, and then you're going to replace this dx, or this 1 dx, with 1, 6 du. And then 1, 6 is a constant, so I'm going to take it out. And then you have secant of u times tan of u du. And what is the integration of secant u times tan of u? That is a known integration rule. It is secant u. This is an n, not an h. That would be secant of u, and then we have this constant, which is 112 plus c. Okay, and then your final answer is 112 secant of u, which is 6x plus 4 plus c. So that's your final answer. Okay, next one. We have the integration of 3 over 7x minus 5 minus 4. This is sin of 2x minus 1 dx. So I'm just going to take the integration separately, right? Because I see like they're separate. So that's what I'm going to do first. So this could be written as this part right here can be written as 3 over 7x minus 5, and then you have a dx minus the integration of this. Okay, and then what I would do next is maybe we could take the integration of this. So 3 is a constant, so it's going to be 3, and then you have 1 over 7x minus 5 dx. And what am I going to do here? So I'm going to have to probably do a u substitution. So my u would be 7x minus 5. Du would be 7 dx. And I have to get rid of this 7 because I don't see a 7 here. So I'm going to multiply both sides by the reciprocal of 1/7. I mean, the reciprocal of 7 would just 1/7. So this would be 1/7 du. This would be dx. You get an integration of 3 over 1 over u, and then you're going to replace dx with 1/7 du. Okay, 1/7 is a constant put in front of 3, so that would be 3/7. 1 over u du. So that would be 3 over 7, and then what's the integration of 1 over u? ln of u. And then that would be 3/7 ln of u, and my u value is 7x minus 5. Okay, over here, the same idea. We're probably going to do u-substitution. So first take out this constant. So that is 4/5. And then you still have a minus. And then you have sin 2x minus 1 dx. And then we'll have to do u-substitution. So that my u would be 2x minus 1. My du would be 2 dx. And then get rid of this 2. So you're going to multiply both sides by 1/2. That's 1/2 du. And then this is just dx. It's going to be sin of u. And then my dx is going to be 1/2 du. And then you still have this 4/5 and the minus. And then 1/2 is a constant, so you could take that out. So that would be 4/5 times 1/2. Then you have sin of u du. And what is the integration of sin of u is negative cosine u. And then you also have this negative 4/5 and this 1/2, which is negative 10. And then we know that 2 negatives becomes a positive, so that's positive 4/10, right? 2 negatives becomes a positive, and then it's cosine of u, and we said our u was 2x minus 1. Let's see, is there anything else you could do here? Yes, this should be 10, but the 4/10 can be reduced by 2. So your final answer is 3/7 ln of absolute value 7x minus 5. 4/10 can be reduced by 2, so that would be 2/5. Let's see. Okay. Okay, the next one, 7. We have sin raised to the 7th x times cosine x dx. So I'm definitely doing u-substitution. And do you know what your u would be? Yes, if you said u was sin of x, that's correct. Because it wouldn't make sense to do cosine x because it wouldn't work out. So what's the derivative of u? Du is cosine of x dx. So it's integration. And then you can replace this sin of 7 to x is the same thing as u to the 7. And then you have a cosine x dx that comes out nicely as du. And what is the integration of u to the 7th? It's just 1/8 u to the 8th plus c. So your final answer is 1/8. And then my u is sin to the 8th of x plus c. Okay, number 8, we have the integration of 3x squared times x cubed plus 5 to the 5th dx. So I'm going to use my u value as x cubed plus 5. And my du is, my du would be 3x squared and then dx. It comes out nicely because we do have a 3x squared here and a dx, so we don't have to get rid of anything. So this is going to be u to the 5th, and then you're going to replace 3x squared dx with du. Yes, nicely. This comes out nice. What's the integration of u to the 5th? It is 1/6 u to the 6th plus c. And then our u is x cubed plus 5 to the 6th power all over 6 plus c. Okay. The next one, 9. We have the integration of x to the 4th all over 2x5 minus 3. So what should I use? I'm definitely going to use u substitution, and I'm going to use my u as 2x to the fifth minus 3. du would be 2x to the fifth, that would be 10x to the fourth, and then the derivative of negative 3 is 0, and then you have a dx. Is there something we have to get rid of? Yes, because we don't have a 10, but we do have this x fourth dx. So yeah, we have an x fourth dx. So that means we have to get rid of this 10 by multiplying by the reciprocal 10, which is 1/10. Okay, so this is 1/10 du, and then 10 times 1/10, that cancels. So you're left with x4 dx. So this is going to be 2x5 minus 3 is u, and then you're going to replace x4 dx. And you're going to replace x4 dx with 1/10 du. 1/10 is a constant, so take that out, factor it out, and then now you're left with 1 over u du. Okay. What is the integration of 1 over u? It's a special one. It's a ln of u, and then don't forget you have this 1/10 plus c, and then finally you just replace your u with 2x5 minus 3. So your final answer is 1/10 ln absolute value of 2x to the 5 minus 3 plus c. Okay. The next one is x squared times sin of x cubed times cosine x cubed dx. What should I use? What should I do? I think I'm going to do u substitution. So be careful. This is not sin cubed of x cubed. It's sin of x cubed, right? This is not the same thing as sin cubed of x cubed. So I'm going to use a u substitution, and I'm going to use my u as sin of x cubed. And then I'm going to do my du. So what is the derivative of sin of x cubed? You kind of have to like use the chain rule. So first, take what is the derivative of sin? It's cosine, and then leave the parentheses alone. Times, then you apply the chain rule. So basically, it's just the derivative of the inside parentheses. So what is the derivative of x cubed? It is 3x squared. And then don't forget you have a dx. Okay, it comes out really nicely. The only thing we have to do is we don't have this 3, right? We have a 1x squared and a dx, right? So I have to get rid of this 3. And to do so, I'm going to multiply both sides by the reciprocal 3, which is 1/3. So this is 1/3 du. And then when you FOIL this out, the 3's cancel, so you're left with cosine of x cubed x squared dx. Okay. And then our u is sin of x cubed, so that's going to be u. And then you can replace cosine x cubed and x squared and dx with 1/3 du. Okay. So then factor do the integration. So 1/3 is a constant, so put it outside. Okay, and then the integration of u is 1/2 u squared, and then you still have this 1/3 plus c. So this is going to be 1/6 u squared plus c, and then it's going to be 1/6, and then my u is sin of x to the third, but be careful, it's raising it to the second power plus c. So you can rewrite this as since we're raising it to the second power, you can rewrite this as sin square of x3 all over 6 plus c. 11. Okay, so we have ex tan of ex times secant square of ex times dx. Wow. Okay, so we're gonna definitely do u substitution. What would I do? Yeah, I think I'm gonna do u substitution. I'm gonna use ex. I'm gonna take tan. I'm gonna use my u as tan of e to the x. I don't know why, but I just feel like that would be right. And then if I take the derivative of that, the derivative of tan e to the x is just secant square of e to the x. And then you do have to apply the chain rule. So basically the derivative of the inside parentheses. So what is the derivative of e to the x? It's just e to the x. And then you have dx. So yeah, it comes out nicely because we have a secant square e to the x. Wait, we have a secant square ex, and then we have this extra ex dx. So it comes out really nicely. So this would be u, and then you can replace this ex secant square ex dx with du, or you can replace this whole thing with du. So this would be du, and then the integration of u is 1/2 u squared plus c, and then finally replace your e with, I mean your u with what? What's 1, and then my u is tan of ex. Square that, and then it's still over 2 plus c. Okay, so your final answer would be, uh, if this is all squared, you can rewrite that as tan square of e to the x all over 2 plus c. And I think 2 more. So let's do 12. The integration of cosine x all over sin cube of x dx. So we'll definitely do u substitution, and I'm going to use my u as sin x because that comes out nicely. My du would be, what's the derivative of sine x? Positive cosine x. And then bring down the dx, so it comes out nicely. So this is going to be 1 over sin cube of x is, we said our u is sin x, so this would be u to the third, and then you're going to replace cosine x and dx with du. Okay. What is the integration of 1 over u cubed? I'm not sure. It's not ln of absolute value. What I would do is rewrite it as a negative power, so it would be u to the -3, and then you have this du. Now we can take the integration of u to the -3, because it would be -3 plus 1 is -2, all over -2 plus c. We can rewrite this as a positive power, so it'd be -2, and then this would be u squared plus c. And then finally, we said our u was, what was our u? Sin x. Your final answer could be -1 over 2, and then it's going to be sin square of x plus c. Final answer. Okay, last one. Integration of 0 to a 4th. So we have a bounded 0, 4, and then we have to take an integration of 2x e to the x squared dx. And I don't think I'll take out this 2. I think what I'll do, because it comes, if my u, I think I'm going to use my u substitution as x squared. So my du would be 2x dx. So it comes out nicely because usually if I took out this 2, I would have to get rid of this 2. So I think I'm just going to keep it. So it's going to be e to the u, and then you're going to replace 2x dx with du. Okay, and what is the integration of e to the u? It's just e to the u, which we said our u was x squared, but we do have bounded boundaries, so we have to use fundamental theorem. So you're going to do the lower on the top and then on top. I mean, the top, it's the upper minus lower. So this would be expressed as e to the upper boundary 4 square minus e to the 0 square. So this is 4 square is 16 minus e to the 0 is just e to the 0. So that's e to the 16. And then what's e to the 0? Or anything raised to the 0? 1. Okay, so your final answer is e to the 16 minus 1. Okay, that's it. That's your final answer. So I hope this refresher kind of helped.